ongoing batch. So I've also covered these chapters and plus coordinate geometry also. And currently I'm doing trigonometry. So today I'm going to start trigonometry with you because anyhow you have to cover that chapter, right?
Okay, ma'am.
Okay. Then we will see, like if you are continuing, then we can see how we work out. Anyway, trigonometry. So you have not done trigonometry yet, right? Right. Okay, so trigonometry is basically a special branch of mathematics, as there are various branches, like one is algebra, there is
Yeah.
geometry, right? So we have trigonometry. Now, what is trigonometry? So trigonometry basically deals with the relationship between, first of all, trigonometry is applicable only on a right angled triangle. Understood? So the triangle, like one angle has to be a right angle. Understood? Okay, I'll write the definition later on, but first understand this thing. It's a right angle triangle and I'm giving some name ABC, correct? Okay, so the side which is opposite to this 90-degree angle is always the hypotenuse, that you know, correct? This is the hypotenuse, that is the longest side of this triangle. Okay, correct? So this is a right angle triangle. Now, if I take this angle, let's say I'm talking about angle C. So if I'm talking about angle C, right? Or I give it a name theta. So this is my angle theta. Now, angle theta is being formed like this is one branch, like one leg of the angle, and this is another leg of the angle, correct? So this is hypotenuse, then this will be called base. Understood? So hypotenuse and base. And the side which is remaining here will be called perpendicular. Got it? Okay, you can
Yes, ma'am. Got it.
unmute your mic. You can unmute your mic so that we can also talk in between.
Okay.
But just don't worry if some background noise is there. All right, so base, perpendicular, and hypotenuse, it is clear, correct? Okay, so as you can see in this triangle, there are different angles. We have angle A, we have angle C, and one angle has to be 90-degree. Now, what is trigonometry? Trigonometry basically deals with the relationship between okay, sides and angles of a right triangle. So you can note it down. So now look at three terms here. First of all, the triangle has to be a right triangle. Then this is the relationship between sides and angles. So it gives you the relationship between sides and angles of a right triangle. This branch of mathematics is called trigonometry, correct? Okay.
Yes, ma'am.
Right. Now we have a trigonometric ratio. The names are this. This is something new for it, but you will get familiar. So the first ratio is called sine of angle theta. Okay, I'm talking about this angle theta. So sine of angle theta, and in short, we write it sine. Okay. Then we have cosine theta, and in short, it is written as cos of theta. Then we have tangent theta, and in short, it is called tan of theta. Then we have cosecant theta. This is called cosec theta in short. Then we have secant theta, and in short, it's called sec theta. And then cotangent, and we call it cot theta, right? So I'm talking about angle theta here. Now, what is sine theta? So the angle is theta, and it is related to sides like this. Sine theta is perpendicular upon hypotenuse, right? Cos theta is base upon hypotenuse. Tan theta is perpendicular upon base. Cosec theta is hypotenuse by perpendicular. Sec theta is hypotenuse upon base, and cot theta is base upon perpendicular, right? So I'll tell you how to remember it, but first of all, these are the ratios. Got it?
Yes, ma'am.
Okay,
And
these
we
are,
have to remember all these things.
yes, you have to remember, but just don't worry. You will get used to it. I'll tell you how.
Okay, ma'am.
Okay, so trigonometry is based upon these ratios. So this is how the sides and angles are connected. right? The perpendicular is actually side, hypotenuse is actually side, and this is the angle theta. So it is giving you the relationship between angles and sides. Got it? Okay. Now come to these three. There are inverse relationship. So just sine theta is actually 1 upon cosec theta. So they both are inverse of each other. If you know sine theta, you can find the value of cosec theta. And if you know cosec theta, you can find sine theta. So they're inverse of each other, right? Similarly, the cos theta is inverse of sec theta. And then the cot theta is inverse of tan theta. So they are inverse of each other. You can note it down somewhere.
Okay, ma'am. Yes, ma'am. Done, ma'am.
Okay. Now how to remember it? Okay, so there's a trick to remember. You just remember this sentence. I tell you. Parents, baby, Priya is happy, happy baby. Okay, just note down this sentence. Okay, first of all, see how I'm using it. Now take the first words, right? So parents, baby, Priya, correct? Leave this is. Now happy, happy baby, right? Now this first is your sine, this is your cos, and this is your tan. So you can see perpendicular by hypotenuse is sine, right? Check here. Then base upon hypotenuse is cos, right? And then perpendicular upon base is your tan, right?
Yes, ma'am. Right.
Okay. And as you know that cosec theta and sine theta are inverse of each other. So if you read it this way, that is h upon p. So that becomes your cosec theta, right? And similarly, cos and sec are inverse of each other. So if you read from here, like hypotenuse upon base, so that becomes your sec. And similarly, this becomes your cot, base upon perpendicular, right? So if you remember this sentence, you can write the trigonometric ratios. So whenever you have a question, you can first of all quickly write this at the corner, I mean this table, and then you can use it in your questions, right? So I think this sentence is easy. Parents, baby Priya is happy, happy baby.
Yes,
So,
ma'am.
okay.
It's
So this way, yeah, this way you can remember it. Now let us see some examples, also some questions from NCERT. And you can check one more thing here. If I take this ratio, let's say sine theta divided by cos theta, right? Okay. Now sine theta is perpendicular by hypotenuse, as you can see, correct? And then cos theta is base upon hypotenuse, right?
right, ma'am.
Right. So this h cancels out and I'm left with perpendicular upon base. Now what is perpendicular by base? That is my tan theta, right? So this is
Yes.
another relationship which you can remember, that tan theta is actually sine theta by cos theta, because I have already checked it. It is coming out to be equal. Let's come to some questions. Exercise 8.1, right? NCERT. Do you have a book, Abdul Malik? The hard copy of the book?
Let me take, ma'am.
Yeah, please get it.
Yes, ma'am. I got it.
Fine. Okay, open exercise 8.1.
Okay, ma'am.
Yeah. Now look at the first question. In triangle ABC, right angled at B. So you make a figure first of all, a right, and this is right angled at B. So this is your B, right? Now anywhere you can write C and A wherever you wish. A here or C here, your wish. AB is 24. So this side is 24 centimeter and BC is 7 centimeter. And now determine. So you have to determine sine of A and also cos of A. Understood? Okay. So the first thing is to find all the sides of the triangle. I mean, this is the first step which will be used in almost all the questions. Find all the sides of the triangle. So if you know all the three sides, then you can write any ratio you wish, correct? Okay, so two sides are given. How can I find the third side here? Abdul Malik, this is a right angle triangle. So I'll use Pythagoras theorem, right?
Yes, ma'am.
Yeah, Pythagoras theorem says that your hypotenuse whole square is equal to perpendicular square plus base square. That is Pythagoras theorem, right? So that means my AC square is equal to AB square plus BC square, right? So
Right.
AC square is 24 whole square and plus your 7 whole square. So my AC square is, how much is 24 whole square? That you can multiply. 4 into 4, 16. 4 into 2, 8 and 1, 9. Then 2 into 4, 8. 2 into 2, 4. So I'm getting 576, right? So 576 and 7 into 7 is 49. So my AC square is, now 6 plus 9 is 15, and then carry 1, 8 and 4, 12 and 6, 25, right? So my AC is square root of 625. Now what is square root of 625? Can you tell me? Okay, do you remember how to find square roots?
Yes, ma'am, I remember.
Okay.
No, ma'am, I forgot, ma'am.
You forgot. Okay, anyway, 625 is a perfect square of 25. So everything is in centimeters. So your AC is 25 centimeter. Okay, I'll tell you how to find. But anyway, this is 25 centimeter, right?
Yes, ma'am.
Okay. So I have got all the three sides. Now you have to find sine of angle A, correct? Now try to understand one thing first of all. Let's say this is the triangle. Now this side is 24, this side is 7, and this side is 25. ABC, correct? Now if I'm taking angle C, then this is my base, right? BC is my base, right? Now if I'm taking angle A, so my base will be AB, understood? And BC will become perpendicular. Got the point?
Yes, ma'am.
Yeah. So hypotenuse will remain hypotenuse, that is the longest side. But base and perpendicular, that depends upon which angle you are taking. Now I'm interested in sine of A. First of all, the formula is perpendicular upon hypotenuse. That's the trigonometric ratio, right? Okay. Now if I'm taking angle A, so which side is my perpendicular?
B.
BC side.
B. Yeah, ma'am.
BC, yes. So BC is perpendicular, hypotenuse is AC, right? Now put the value. So BC is 7 centimeter and AC is 25 centimeters. So centimeter gone, and 7 by 25 is sine of A. Similarly, you can find cos of A. Now cos of A is how much? Base upon hypotenuse. Now which side is base? If I'm taking angle A here, which side is base?
Base, ma'am, I think 24.
Side, yeah. First of all, write the name of the sides, that is AB and AC, right?
24 by 25.
Yes, 24 and divided by 25. So that is cos of A. So this is how trigonometric ratios are used in a triangle. Now second part also we can do right here. Now you have to find sine of C also. Now look at angle C this time. Okay. Again, the ratio is perpendicular upon hypotenuse. Now which side is perpendicular? Tell me.
A.
A is just angle. Side is either AB or BC or AC, like that.
AB, ma'am.
AB, good. And hypotenuse?
BC.
Hypotenuse is always hypotenuse. That is AC.
AC. Oh, okay, AC, ma'am.
Hypotenuse is this, the side which is opposite to this 90-degree angle, that is hypotenuse. Okay. It will always be AC. Okay. Now AB put 24 and AC is 25. So that is your sine of C. Similarly, I am going to find cos of C now. Cos of C is again base by hypotenuse. Now tell me which is base if I'm taking angle C.
BC will be base, ma'am.
And hypotenuse?
AC.
AC, good. So BC is 7, AC is 25. That's the value of cos C. So this was the first question.
Yes, ma'am. I find it this question easy, ma'am.
Yeah, this is direct application. Okay. So are you noting it down or should I move forward?
No, ma'am, I'm noting it down.
Okay, please write.
Done, ma'am.
Okay. Next question also. It's quite similar. Second question you can see in your book. So in the given figure, so there's a figure which is already given. And this is PQR. Now this side is 12 centimeter and this side is 13 centimeter. And this is the 90-degree angle. So which side, which side is hypotenuse in this triangle?
PR.
PR, very good. Now you want to find the value of tan P minus of cot of R, right? Okay. Now what is the first step I told you? In every question, the first step is to find all the sides of the triangle, right?
Yes, right.
In the previous question also I told you, right? So to find this, we can use Pythagoras theorem. So that means your hypotenuse square is equal to perpendicular square plus base square, correct? Sorry, square. Now hypotenuse is PR square is equal to PQ square and plus QR square, right? So
Right,
I don't know QR, so I'll keep it on one side. So PR square minus of PQ square is equal to your QR square. Now this I know, 13 whole square minus 12 whole square is equal to QR square. So 13 into 13 is 169 minus 12 square is 144 is equal to QR square. So some common squares you can remember, right? Squares and square root, at least
yes.
up to 15 or up to 20, you should remember. So that thing makes your things easy. Now 9 minus 4 is 5 and then 6 minus 4 is 2. 25 is equal to QR square and then under root of 25 will be your QR. That means your 5 is equal to your QR, right? So your QR has come 5 centimeter. So now I know all the sides, I can find any trigonometric ratio now. So I'm interested in
Ma'am,
tan.
I'm having a doubt.
Yeah, sure.
How we got 5 from root 25?
25 is perfect square, right? 5 into 5 is
Yes.
25, right?
Yes, ma'am. Yes.
Okay, and then you take square root, so you have a pair, so one of it will come out, right?
Yes. Okay, ma'am.
So you can just go through the chapter squares and square root of class 8. That will help you to revise how to find square roots, etc. Otherwise, like I'll tell you sometime like how to find square roots of big numbers. Okay. Anyway, now I want to find tan of P, right? So what is the trigonometric ratio formula tan? Look at the table and tell me.
Ma'am, P by D?
Yeah, perpendicular by base, right? Okay.
Yes, ma'am.
So this is perpendicular divided by base, right? Now my angle is P, right? Now tell me which side is perpendicular. This is my angle P.
QR.
Very good. And base?
Base will be PQ.
Very good. So QR is 5 centimeter and PQ is 12 centimeters. So centimeter will cancel out. 5 by 12 is the ratio, right? And now I want cot of R also. Cot of R, that means I'm looking at this angle now, right? First of all, what's the formula? Cot. Yeah, the last one. Look at the last one in the table.
B by P.
Base by perpendicular. Yeah.
Perpendicular.
Cot is actually inverse of tan, right? So it is perpendicular by base. This is base by perpendicular. Okay. Now look at angle R. Now which is base? Which side?
Base will be PQ.
You are taking angle R this time. You have to look at this angle which you are taking here. R is being made. This is one leg, right? Look at R. So this is the leg QR, right? QR is the base.
5.
Perpendicular is
PQ.
PQ.
PR. PA.
No, PR is hypotenuse. Always. PQ is perpendicular, right?
Yes, ma'am.
The side which is opposite to this 90 degree is always hypotenuse. Okay.
Okay, ma'am.
So don't get confused with hypotenuse. Okay. QR is again 5 centimeter, PQ is 12 centimeter. So again 5 by 12. Now you have to find the value of 10p minus of cot R. So 10p you have found 5 by 12 and minus of 5 by 12. So this is equal to 0.
I have noted this, ma'am.
Okay, so till other students, I actually have a class now, but anyway, till the students are coming, we can take up one more question. Question number 3. So this time it is given that sine of A is equal to 3 by 4. So now you see the sides are not given, right? The measurement of side is not given, but the trigonometric ratio is given. So it's a different type of question, right? Okay, you have to find cos of A and tan of A you have to find. Now you don't have the figure, right? So you have to draw a figure. Now how will you draw? First of all, write down, okay, you make a triangle and it has to be a right angle triangle. Got it? Now you can see A, so give it some
Ma'am,
name.
in this chapter, we have to always draw this triangle only.
No, not always, but at first exercise, in first exercise, you require it.
Okay, ma'am.
Yeah. Okay. Now, one more thing, these angles, right, which I write sine of A or sine of, so whatever angle you have, it is actually the acute angle of the triangle, right? The trigonometric ratios are found. Let's say I have a triangle ABC. So this is the right angle. So either we find of angle C or we take angle A, correct? So both A and C are acute angles. So whichever angle is given here, it's one of the acute angle of the triangle, right? So you have to take A here or you have to take your A here. I mean, not here. Got it? Because the figure is not given. So you have to take it accordingly. You cannot take your A here because it should be one of the acute angle. So wherever you wish, you can take. So I'm taking my A here, right? Now B and C, you can take anywhere. Let's say this is B, this is C. And this angle is 90 degree. Okay. Right? This is the figure. Now see sine of A. Now what is sine? Sine is perpendicular upon hypotenuse, correct?
Yes, ma'am.
Okay, now because I'm taking A, that means this one is my angle. So my perpendicular is BC and my hypotenuse is BA, right? Or AB. Now this is given to be 3/4, correct?
Yes, ma'am.
Got this thing? Okay. Now can I say BC is equal to 3 and BA is equal to 4? Hello, yes, just a minute. Hello, Sarah, can you hear me?
Yes, ma'am.
Yeah, Sarah, just give me 2 minutes. I'm just winding up this question, okay? Okay, please stay here. Yes, Abdul Malik. Yes, are you here, Abdul Malik?
Yes, ma'am.
Okay. Now, can I say BC is equal to 3 and your BA is equal to 4? What do you
Yes,
think?
ma'am.
Are you sure? See, Abdul Malik, here is the catch in this question. I cannot say BC is equal to 3 and BA is equal to 4. I mean, it is correct, but it is one of the correct answer. There are many other answers to this. Why? See, for example, my BC is, let's say, 12, right? And my BA is 16, right? Now I want to take BC upon BA. So this will be 12 upon 16 and you cut it from the table of 4. So again, you will get 3/4. So how can I say that my BC is always 3? It can be 12 also, right?
Yeah, right, ma'am.
Basically, the ratio is always 3/4, not the sides are always 3/4. Got the point?
Yes, ma'am.
Okay. So I'll not say BC is equal to 3 and BA is equal to 4, but I can say that BC is 3 times something and 4 times of some number. That I can say, right? So it is always a multiple of 3. It is always a multiple of 4. Got the point?
Yes, ma'am. Got.
So that's how I'll take my side. So now BC is 3 of X and AB or BA, this is 4 of X. So this is how I'm going to take the two sides of my triangle. Right? Okay. Now, first step is always to find the third side. So again, you will use Pythagoras theorem. So basically your AB square is BC square plus AC square according to Pythagoras theorem. So AB square is 4x whole square is equal to 3x whole square and plus AC whole square. So 4x whole square minus of 3x whole square is equal to your AC square. So this is 16x square minus 9x square is equal to AC square. And 16 minus 9 is 7x square is equal to AC square, right? So under root of 7x square is AC. And because you have a square here, so this will be under root 7 and x will come out. So this is your AC. So my AC is under root of 7 into x, right? Now I have all the three sides of the triangle. So any ratio I can find out now. So I want to find cos of A. Now cos of A is base upon hypotenuse, right? So if I'm taking angle A, my base is AC and hypotenuse is AB. So that means under root of 7 of x and divided by hypotenuse, that is 4 of x. So x and x will get cancelled out and under root 7/4 is the answer, cos of A. Similarly, you can find tan of A also. Okay.
Okay, ma'am.
So Abdul Malik, actually I have a class now. So your class is ending. And yeah, so I mean, whatever, then I mean, you can communicate with the office after this. The office
Okay,
will
ma'am.
call you actually. Yeah. Okay. Right. So you can leave now. Okay. Thank you.
Okay, thank you, ma'am.
Okay. Thank you. Yes, Abdullah, you are here. Sarah, you are here.
Yes, ma'am.
Sorry, I had another class before this. Okay, Abdullah, how are you?
Fine.
Okay, what were we doing in the previous class? Tell me.
Exercise 8.3.
8.3. Okay. Completed?
Yes.
Okay. Sarah, were you there in the last class? You were not there, right?
No, ma'am, this one.
So you have missed exercise 8.3, Sarah, and today I'm going to start with exercise 8.4. Okay.
Yes, ma'am.
You can get the recording from the office for exercise 8.3. 8.4 now. All right. So Abdullah, in the first exercise, we were doing trigonometric ratios, right? Then in the
Yes.
second exercise, what were we doing?
Trigonometry table, and then after that we were doing trigonometry ratios of complementary angles,
Very good.
and
Oh.
now I think so trigonometry identities.
Identities. So today we are going to learn about trigonometric identities. Now, what is an identity? Why we call it identity? Can somebody tell me? What do you understand by identity? See, this is one identity you have learned. A plus b whole square is equal to a square plus 2ab plus b square, right? This is one of the identity you have already learned. Why we call it identity? Okay, identity is something, which is already proved. It is, you don't have to prove it. It's always true, correct? It is
Yes,
already proved that it is correct. So you don't have to show it again and again. I mean, in the questions, you will not first of all show that a plus b whole square is equal to this square, and then you will use it. I mean, you can directly use it, correct? So that is why it is an identity. It is always true. Got it?
Yes,
Okay.
ma'am.
So similarly, we have 3 trigonometric identities. That means you don't have to prove them, but you can use them in the questions. It's already proved. So the first one is that sine square theta plus cos square theta is equal to 1. Now theta can be any angle, so it's always 1. Now second identity is 1 plus tan square theta is equal to sec square theta. And the third identity is 1 plus cot square theta is equal to cosec square theta. So these are the 3 trigonometric identities. Right? So if you first one is easy, sine square plus cos square always 1. Now, if you get confused in the second and third, so remember it like this, like you have C in one of the identity, both are C. So that way you can remember. Understood?
yes, ma'am.
Yes, ma'am.
And then tan and cot are actually inverse of each other. So they fall on one side, like 1 plus tan square and 1 plus cot square. And the remaining one, then you can write. So that way it can help you to remember. Let us see some questions. So you will see how do we use it. Exercise 8.1, first question. Now express the trigonometric ratio sine A, sec A, tan A in terms of cot A. For example, like you have to write sine of A in terms of cot A. Understood?
Yes, ma'am.
Okay. So if I use this identity, the third one, I know that cosec square theta, okay, you use it like this, 1 plus cot square theta is equal to cosec square theta, correct? Right? Okay, before this, you see this thing. Okay, now we know this thing that sine theta is 1 upon cosec theta. This we know, inverse relationship.
Yes, ma'am.
Correct? Okay. Now you use this third identity that cosec square theta is equal to 1 plus cot square theta, right?
Yeah.
Okay. That means your cosec theta is under root of 1 plus cot square theta. Correct?
Yes, ma'am.
Okay. Now cosec theta is 1 upon sine theta. So 1 upon sine theta is under root of 1 plus cot square theta. And if I want to find the value of sine theta, so basically I cross multiply, right?
Yeah.
So my sine theta will become, or you take inverse on both the sides. So sine theta is 1 upon under root 1 plus cot square theta. So this way I have expressed sine theta in terms of cot theta. Got it? As you can see on the right side, I don't have any other trigonometric ratio, only cot theta is there. So sine theta is expressed in terms of cot theta. Now you have to express sec theta also, right? Sec theta in terms of what? Cot theta. So you use this second identity. Like if I want to find sec theta, so I have this identity that 1 plus tan square theta is equal to sec square theta, correct? Okay.
Yes, ma'am.
So 1 plus, now tan I can convert in cot. So 1 plus cot square theta is equal to sec square theta, right?
Yes, ma'am.
Okay. Now you take LCM. So this is cot of square theta, and then this will become cot of square theta plus 1 is equal to sec square theta, right? Any problem at this step, Sarah?
No, ma'am.
No. So I want to find sec theta. So I have to take under root. So under root of cot square theta plus 1 and divided by cot square theta, I mean under root of full, is equal to my sec theta. So the square is gone. Now in the denominator, you can see I have square root also, and then I have square also. So the denominator will become cot square only, and only the numerator will remain under square root. So cot square theta plus 1 and divided by cot of theta is equal to sec of theta. So you can see I have expressed sec theta in terms of cot theta. If you have any sort of confusion, any little confusion at any step, you can tell me. Yes, Sarah, any confusion?
No, ma'am.
Okay, Abdullah,
Yes, ma'am.
any confusion here?
No, ma'am.
Okay, now tan A you have to find in terms of cot A. Tan A, we know it's only reciprocal of cot A, that's it. So tan A is equal to 1 upon cot A. So you have seen I have expressed like sine theta in terms of cot theta, then tan theta in terms of cot theta, and then sec theta in terms of cot theta. Got it? Written?
Yes, ma'am. Yeah.
Okay, next question. Second question. Now write all the other trigonometric ratio of angle A in terms of sec A, right? So you have sec of A. Now you have to write all the other trigonometric ratio in terms of sec A, correct? How do we write? So I take the first identity, let's say sine square A plus cos square A is equal to 1, right? So I want to find sine A. So I'll keep sine square A on one side, and it becomes 1 minus of cos square A, correct? Now, because I want to know everything in terms of sec, so I'll convert this cos in sec. So this becomes 1 minus 1 upon sec square A, right, Abdullah? Okay, so now you take LCM. So sine square A is equal to, LCM will be sec square A. So this will be sec square A minus 1. And then your sine of A will become square root of sec square A minus 1 and divided by sec square A, right? So this,
Okay, ma'am.
I can write sine A, so I can just break the square root. So sec square A minus 1 and divided by under root of sec square A. Now look at the denominator, there's a square also, there's a square root also. So they will cancel out and it will become sec square A minus 1 and divided by only sec A. So you have seen I have converted like sine theta in terms of sec theta. Yes?
Yes,
Okay, next ratio is cos theta. Cos theta is simply inverse of sec theta. So cos A is 1 upon sec A. So I have expressed cos A in terms of sec A. Right?
Yes.
Okay. Now I want to find tan of A. Next is tan. Right, Abdullah? Now, whenever you
Yeah,
have,
ma'am.
okay, whenever you know the value of sine and cos, so use this formula. Tan A is equal to sine A by cos A, right? This you know,
Okay.
sine A by
Yeah.
cos A. Yeah.
Yeah,
Now,
ma'am. I know.
now sine A, you know, put it here. Sine A is sec square A minus 1 divided by sec A. So you have to be very careful with the calculations now. Cos A is 1 upon sec of A, right? Now, both the denominator are same. They will cancel out, right? So you are left with under root of sec square A minus 1 and then divided by 1. So that is under root sec square A minus 1. So that is tan of A. So I have found tan of A also, right?
Yes, ma'am.
Okay. Now only these three you need to find. Other three you can find, just take the inverse, right? So cosec A is nothing but 1 upon sine A, that you already know, right? And now whatever sine, take its reciprocal. So sine you already know. So this will become sec A divided by under root of sec square A minus 1, correct?
Yeah, ma'am.
Okay. And then sec A you don't have to find because sec A is sec A. Next is cot of A. Cot of A is inverse of tan A, right? 1 upon tan A. So you have already found tan, take its inverse. So it becomes 1 upon under root sec square A minus of 1. That is your cot A. So ultimately, what is important to find? Sine of A and cos of A. That's it. If you know sine and cos, you can find all the others because tan A is also sine A by cos A, right? Just take the ratio. Then cosec is 1 upon sine, cot is 1 upon tan, sec is 1 upon cos. So only sine A and cos A are important to find. Got it?
Yes, ma'am.
Yeah.
Hmm. Okay. Next question now. Written all of you?
Yes, ma'am.
Yes, ma'am.
Third question. Now, third question is sine square of 63 degree. This is the third question, right, in your book?
Yes,
Divided
ma'am.
by, yeah,
Yeah, ma'am.
cos square of 17 degree plus cos square of 73 degree. So you have to find its value. Identities are not even required here. You can use the complementary relationships, correct? So now look at this numerator 63 and 27. So 63 plus 27 is 90, right?
Yes.
Yeah, you can use the identity. You will do one thing. Any 63 or 27, like any of them you can convert. So I want to convert 63. So this 63, I'll write like this, 90 minus of 27. Any problem?
No, ma'am.
No?
No, ma'am.
Then I have sine square of 27. And similarly, in the denominator, I can see 17 plus 73 is equal to 90. So I can write this like this. Now this 17, I can write 90 minus 73. No problem. Plus cos square of 73. Okay. Now I know that sine of 90 minus theta is cos of theta, correct? So whatever is subtracted from 90, that becomes your cos theta. So now 27 is subtracted. So I'll get cos square of 27 because I have square outside. So this will come, correct? Cos square
Yeah,
of 27 and then sine square of 27, sorry, divided by. Similarly, cos 90 minus theta is sine theta. So this time it will become sine square of 73 plus cos square of 73. Now you look at this identity, that sine square A plus cos square A is equal to 1. So basically the angle has to be same. So I have made my angles same. Now this is cos square 27 plus sine square 27. So this is 1 divided by. Similarly, sine square 73 plus cos square 73 is 1. So the answer is 1.
Done, ma'am.
Okay, done, Abdullah. Next, second part of this question.
Yes, ma'am.
Okay, the second part is this, that sine of 25 degree into cos of 65 degree plus cos of 25 degree into sine of 65 degree. Again, this is similar kind of question. You can convert one of the sine into cos and then cos into sine, whatever. So let's start from here. This 25. Now you can see 25 plus 65 is 90, right? Yes?
Yes, ma'am.
Yeah, 25 plus 65 is 90. So I can write this 25 as 90 minus of 65, no problem. And then I have cos of 65 plus. Now, similarly here, I can convert this 25. So this 25, I can write 90 minus 65. And then I have sine of 65 here because 65 plus 25 is 90. Now, sine 90 minus theta will become cos theta, right? So this will become cos of 65. And then there is one more cos of 65 plus. Now cos 90 minus theta will become sine theta. So sine of 65 and then another sine of 65. Correct, Abdullah? So that
Yes, ma'am.
becomes your cos square 65 and plus this becomes your sine square of 65. Now you can see both the angles are same. So sine square theta plus cos square theta, that is 1.
Done, ma'am.
Okay. Next, third question. First part. Choose the correct option, justify your choice. So first part is this, 9 sec square A minus 9 tan square A. Okay, so we will find the value. So you can take 9 common, right? So that is sec square A minus of 10 square A. Now there's an identity, you know, that 1 plus 10 square A is equal to sec square A, correct? So that means 1 is equal to sec square A minus of 10 square A. You can take the 10 that side. So that means this is 9 into 1 and this is equal to 9. So the correct option is B. You will write this thing, right? In this, on the side, you will show this thing. This is like part of question. Now second part. 1 plus tan theta plus sec theta into 1 plus cot theta minus of cosec theta. So you have to find its value, right, Abdullah?
Yes, ma'am.
Okay, so whenever you have so many different ratios, so what we do it, we convert everything in terms of sine and cos first of all. So this I'll write as 1 plus tan theta is sine theta by cos theta, right?
Yeah,
Plus
ma'am.
sec theta is 1 upon cos theta. So this is one bracket. And then 1 plus cot theta is inverse of tan, that is cos theta by sine theta, minus 1 upon 1 upon sine theta. Yes, Sarah? No problem.
Yes, ma'am.
Now, because you are adding fractions, so you will take LCM. So take LCM here, cos theta, right? So the first term becomes cos theta plus sine theta plus 1. Yes.
Yes.
Similarly here, you take your LCM, that is sine of theta. So 1, this will become sine of theta plus, then you have cos of theta and minus 1, right? Okay. So you can like directly multiply it also, there's no problem. Or you can use an identity here, Abdullah. If you can see, there's an identity that a square minus b square is a plus b into a minus b, correct?
Yeah, ma'am.
So if I want to use this, so I can see here, like if I combine this into one, so let's say this is my a, right? So this is a plus b and this is a minus b, right?
Yes.
Yes.
Yeah, yeah.
Okay, so I can write a square minus b square. So the numerator will become like cos theta plus sine theta whole square and minus 1 whole square. Any problem, Sarah?
No, ma'am.
No? Okay, and divided by cos theta into sine theta. Yes? Okay.
Yes, ma'am.
Yeah, ma'am.
Right. See, in trigonometry, you have to be very like step by step, you have to do very careful with the calculations. And sometimes it's a lengthy one. Okay, now, so this is a plus b whole square. So we do it a square plus b square plus 2ab. That means cos square theta plus of sine square theta plus 2 into cos theta into sine theta, right? And then minus 1 and divided by cos theta sine theta, right? Now you take this cos square theta plus sine square theta, that becomes 1 from identity, plus 2 cos theta into sine theta and minus 1 and divided by cos theta into sine theta. Now this 1 minus 1, 0 in the numerator, 1 cancel out. So only 2 cos theta and sine theta and divided by cos theta and sine theta. Now this cos theta sine theta will cancel out each other and answer is 2. So the correct option is C.
Ma'am, can you explain this question again?
Which one, Sarah? This
This
step?
question, second. Yeah.
This one?
Yeah.
Okay. So because okay, from here you can say this is a plus b whole square, right? So a plus b whole square is how much? A square plus b square plus 2ab. That's another identity, right?
Yeah.
So if I have cos theta plus sine theta whole square, so that means I'll get cos square theta plus sine square theta and plus 2 cos theta into sine theta. Now we know that sine square theta plus cos square theta is 1. There's an identity.
Yeah.
So this complete thing becomes 1. So I get 1 plus 2 cos theta and sine theta. So that's I have written.
Ma'am,
And
should we write the identity in the side?
yes, you will write like in the side, you will mention it, right? So whatever identity you are using, you put it a bracket here and then you mention the identity, correct?
Yes, ma'am.
That we always do. Whatever identity we are using, like at the side in a bracket, we write this, that we are using this identity at this step.
Done, ma'am.
Yeah, Abdullah, any confusion in this question?
No, ma'am, no confusion.
Right, next one. Third part. Third part is sec of A plus tan of A into 1 minus of sine of A. See, this is easy. It's not very difficult. Now you convert everything in sine and cos first of all. So 1 upon, sorry, sec A is 1 upon cos A, correct? Plus
Yeah.
tan A is sine A by cos A. So you have to remember the ratios, relations, that's it. Then you can do calculations. Then 1 minus sine of A, right? Okay. Now here we have fractions. We are adding fractions. So take LCM. LCM is cos of A. So that becomes 1 plus sine of A. And then I have 1 minus sine of A. Okay. Now again, this is A plus B into A minus B in the numerator. So that becomes A square minus B square, right? So this becomes 1 square minus sine of A whole square, correct? A square minus B square. And then I have cos of A. So this I get 1 minus sine square A divided by cos of A, right? Now you look at this identity at sine square A plus cos square A is equal to 1. So if I take this sine square on the right hand side, so I'm left with cos square A is 1 minus sine square A. So like in place of 1 minus sine square A, I'll get cos square A. So this becomes your cos square A and divided by cos of A. And this will only cos A. Like one cos will cancel out. So only cos of A will remain.
Yeah.
So the answer is D. Correct option is D. Okay, done, Abdullah.
Yes, ma'am, finished.
Okay, fourth part. Fourth part is 1 plus tan square A and divided by 1 plus cot square A. Okay. Now to solve this, there are two options. You can convert it in sine and cos also, but here I can see it is direct identity, right? 1 plus tan square A is sec square A. See identity number 2. And then 1 plus cot square A is cosec
Cos
square
square
A.
A.
Yeah. Now you can convert in sine and cos. So, I mean, it will make things simple. Otherwise, you have to take LCM and then add and everything. Okay. Now, sec is 1 upon cos square A, right? And cosec square is 1 upon sine square A, correct? Okay.
Yes, ma'am.
So now this will go in the numerator and this will come in the denominator. So I'll get sine square A and divided by cos square A. Any problem at this step?
No, ma'am.
No, Abdullah? Now sine A upon cos A is tan A. So this becomes tan square A. So correct option is D.
Ma'am, up there you did cross multiplication, right?
It's not cross multiplication. Basically, we are dividing fractions, fraction upon fraction. Cross multiplication is this, Sarah. For example, I have x upon 2 is equal to 4 upon 3, let's say, right? So when you have equal to sign in between, then it is called cross multiplication, that I multiply 3 here and then I multiply 4 here. So you can see there's a cross in between. So I write 3 into x and I write 2 into 4. This is cross multiplication. Got it?
Yes, ma'am.
Yeah. Now this is fraction upon fraction. So look here. How do we do it? For example, you have a fraction a upon b and then divided by another fraction r upon s. Correct?
Yeah.
Now, how do we simplify it? So the things which are outside, they are multiplied together and they go in the numerator. Okay. And the numbers which are inside, they are multiplied together and they come in the denominator. So it will become s into a divided by b into r. So this is how we divide fractions.
Okay, ma'am.
Correct?
Yeah.
Got it, Abdullah? So the same thing I'm doing here. So you can see sine square a into 1 and then divided by cos square a into 1. So this 1 actually cancels out. So I've written directly sine square a by cos square a. You can add this step if you wish. So please note this also, Sarah, somewhere. I think you keep forgetting. So you can note this thing in a box somewhere. So this is how we divide fractions.
Okay, ma'am. Done, ma'am.
This is something we write it like this also, like in the previous, in your junior classes you have done it. For example, I have 1 upon 2 divided by, let's say, 3 by 4. Yes, Abdullah?
Yeah,
So
ma'am.
first of all, what we do, Sarah, we convert this division sign into multiplication. So what we do is we write 1 upon 2 multiply and then we make its reciprocal, so it becomes 4 by 3. Simple. It's the same thing as this.
Yeah.
Yeah. So basically you check here. See, I'm dividing a by b. I'm dividing by r upon s. So I'll write a by b, multiply, and then I'll make it reciprocal. So s by r. So see, I'm getting the same thing.
Yeah.
Yeah. So that's how we divide fraction. So we convert the sign into multiplication and then we take the reciprocal of the another fraction. So these are small things which you have already studied, but due to lack of practice, you people actually forgot these things. You don't practice questions. So please make a habit of practicing questions. Okay.
Yes, ma'am.
Right. Now question number 5. These are actually important things. Okay. These are little things, but if you don't know, how will you do calculations? Okay, prove the following identities where the angles involved are acute angles for which the expressions are defined this. Okay, so first question. Cosec theta minus of cot theta whole square is equal to 1 minus of cos theta and divided by 1 plus of cos theta. Okay. Right? So let us solve the LHS. Let us check whether it is coming out to be equal to RHS or not. So my LHS is this cos theta minus of cot theta, but whole square. So first of all, I'll convert it into sine and cos. 1 upon sine theta minus cot is cos theta by sine theta, inverse of tan, right? Whole square. Right? Okay.
Yes, ma'am.
Now I can use a minus b whole square also, or I can do one thing, I can take LCM sine theta, right? So this will be 1 minus of cos theta whole square. This I can write. So this becomes 1 minus of cos theta whole square and divided by sine square theta, correct? Okay.
Yes, ma'am.
Now this sine square theta, now see identity number 1. What can I write in place of sine square theta? Abdullah, you tell me from identity number 1. Yes, Abdullah, are you here?
Yeah, ma'am, I'm here.
Okay, what can I write in place of sine square theta? See, what is identity number 1? It's sine square theta plus cos square theta is equal to 1, right?
Yes, ma'am.
So I want to find the value of sine square theta only. So that means I can take this cos square theta on the other side. So sine square theta is 1 minus cos square
Minus
theta.
cos theta.
Cos square theta, okay?
Yes.
So I'll write this 1 minus cos theta whole square divided by, this is 1 minus cos square of theta, correct?
Yeah, ma'am.
Okay, so 1 or 1 square is same thing, right? So can I take it a square minus b square in the denominator?
Oh, yeah, ma'am.
Okay.
Yes.
Okay, so this is 1 minus cos theta whole square. So I'm writing it 2 times, 1 minus cos theta into 1 minus cos theta, no problem. And then I have a square minus b square. That means a plus b into a minus b. Okay, Sarah?
Yes.
Any confusion? Okay,
No.
now one bracket will cancel out and only 1 minus of cos theta and divided by 1 plus of cos theta will remain, which is equal to your RHS. So you have proved. So at this step, I'm using this, a square minus b square is a plus b into a minus. Actually, at this step, right? This step I'm using a plus b, a minus b. Written?
No, ma'am. 1 minute. Done, ma'am.
Okay, next. Second part. So this is cos of a divided by 1 plus sine of a plus 1 plus sine of a and divided by cos of a. This is 2 sec of a, right? So we start with the LHS. Yes, Abdullah? Let us take the LHS. Okay, this is my LHS. Now these are fractions, so I have to take LCM, right? Now what will be the LCM? So LCM will be 1 plus sine of a and multiplied by cos of a. Yes?
Yes, ma'am.
Okay. So here 1 plus sine a is there. So the cos a multiplied by cos a. So it will become cos square a, correct? Plus, now cos a is already here. So it will be 1 plus sine of a whole square. Any confusion?
No, ma'am.
Okay. Now I have cos square a plus. So this is now a plus b whole square, right? So a square plus b square and plus 2ab. That means 2 into 1 into sine of a. And then divided by 1 plus sine a into cos a. Okay. Now you look at this. Cos square a plus sine square a. So cos square a plus sine square a becomes 1. Yes, Abdullah?
Yes, ma'am.
So this cos square a, or you can like put it in one, if you have confusion, just write it together, and then plus 1 square is 1 plus 2 sine A, right? Okay, if you don't want to do it directly. So 1 plus sine A into cos of A. So like if you take it together, like cos square A plus sine square A, that becomes 1. So I have 1 plus 1 plus 2 sine A and divided by 1 plus sine A into cos of A, right? Okay. So this becomes 2 plus 2 sine A divided by 1 plus sine A into cos of A, right? Now I can take 2 common. So I get 1 plus sine of A and divided by 1 plus sine of A into cos of A. So now this whole bracket 1 plus sine A and 1 plus sine A will get cancelled out. So I'm left with 2 into 1 upon cos of A. Now 1 upon cos A is sec A. So this is 2 sec of A. This is equal to RHS. Yeah, Abdullah, any problem here?
No, ma'am. No, ma'am.
Okay.
Done.
Hmm. Done? Okay, next now. Third question. So I have tan theta divided by 1 minus of cot theta plus cot theta divided by 1 minus of tan theta. Okay, so this I have to show 1 plus sec theta into cosec theta, right? Okay. Now, one thing is that I think I should convert it into sine and cos on the left hand side. So I take my LHS. So, okay, I'm writing it directly. Now, tan theta is sine theta by cos theta, right? And then
Yeah.
divided by, now I have 1 minus, now cot theta is cos theta divided by sine theta. So write it very carefully. Plus, now this cot theta is cos theta divided by sine theta and then divided by 1 minus sine theta by cos theta. Yes. So I have converted into sine and cos. Now do it carefully. So in the numerator, I have sine theta upon cos theta. And then in the denominator, I'll take LCM because I'm subtracting fraction. So sine theta, right? This becomes sine theta minus of cos theta. Yes, Abdullah? Okay, plus. So I have cos theta divided by sine theta and divided by, again, I take LCM cos theta. So this becomes cos theta minus of sine theta. Fine, Abdullah?
Ma'am.
Okay. Again, Sarah, you multiply like the outer ones will be multiplied together. So it will be sine theta into sine theta. Got it? And then divided by cos theta with this bracket. Sine theta minus cos theta. Plus. Now again, the outer ones will be multiplied together. So cos theta into cos theta. And then sine theta with this bracket, cos theta minus sine theta, right? Okay, now they are again fractions, so I have to take LCM. Without taking LCM, I cannot add the two terms. They are fractions, right? So the LCM this time will become, I can do one thing first of all before taking LCM. Now you see here very carefully, Abdullah. This is sine theta minus cos theta in the first bracket, okay? But in the second bracket, I have cos theta minus sine theta. So if I take minus sign outside, it will become sine theta minus cos theta. Abdullah, are you here?
Yes, ma'am.
See here, I have cos theta minus sine theta in the second bracket. Okay, Sarah?
Yes, ma'am.
I mean, this term is plus and this term is minus. If I'm taking the minus sign outside, so my plus term will become minus and my minus term will become plus, correct? So I can just flip it and I can write sine theta minus of cos theta, no problem. So
Yes, ma'am.
this will become same as this sine theta minus cos theta. So I'm taking a minus sign common from this second bracket, right?
Yeah.
Okay. So I'm taking a minus sign common. So that becomes here now. Okay, this becomes sine square theta divided by cos theta into sine theta minus cos theta. Okay. Now here, if I take the minus sign outside, so that minus and this plus will become minus. So I have a minus now. Got it?
Yeah.
Yes, Abdullah. And here I have cos square theta and then divided by sine theta into, so this now becomes sine theta minus cos theta. All right.
Okay, ma'am.
Okay. So again, now take LCM because I have same things in the denominator, so I can take LCM now. So the LCM will become sine theta into cos theta and then this bracket sine theta minus of cos theta, right? Now cos theta and this bracket is already there. Only sine theta will be multiplied with the numerator. So it will become sine of cube theta, right? Minus. Similarly, sine theta and this bracket is already there. Only cos theta will be multiplied. It will become cos cube theta in the numerator. Okay, now I have an identity. I'm writing it here, right? I have some space now. A cube minus B cube. What is the formula for A cube minus B cube? So in
A
case
minus B.
yeah, A minus B into
A square plus B square plus
plus
AB.
plus AB. Okay, you have to remember it. Okay, this is an identity. A cube minus B cube is equal to A minus B into A square plus B square plus AB. Everything is plus, only you have minus here, A minus B. So A cube minus B cube I'm doing in the numerator. So that becomes your sine theta minus of cos theta. And then A square, that means sine square theta plus cos square theta plus AB. That means sine theta into cos theta, right? And then the denominator, whatever you have. So sine theta, cos theta, and then you have sine theta minus of cos theta. Fine, Abdullah, so far?
Yes, ma'am.
Okay. Now you see here, this whole bracket sine theta minus cos theta will cancel out with this bracket. Okay. Sine theta minus cos theta, they will cancel out. Now this sine square theta plus cos square theta will become 1, right? So
Yeah, ma'am.
I have 1 plus then sine theta into cos theta. And then in the denominator, I again have sine theta into cos theta. Now I'm just splitting my denominator. So it becomes 1 upon sine theta cos theta and plus sine theta cos theta divided by sine theta cos theta, right? So this actually cancels out. And this 1 upon sine theta becomes your cosec theta, and 1 upon cos theta will become your sec theta, and plus 1. So that is your RHS.
Done, ma'am.
Okay. All right. Sarah, you did not attempt the test of coordinate geometry?
Say again?
There was a test of coordinate geometry last week. So
Yeah, I didn't.
why you did not attended that test?
I think I wasn't there.
Sorry?
I think I wasn't there at the time.
Sarah, I mean, you are supposed to attempt all the tests, right? Now, in the coming week also, I'm going to take one test on trigonometry.
Yes, ma'am.
Today is Tuesday. So I want to have a test on Saturday. Fine, Abdullah?
Okay, ma'am. Yes.
Saturday, there'll be a test of trigonometry. Like we are already on the last exercise. So I suppose in the next class, we will finish trigonometry. So I'm going to take a test on Saturday. Okay. So Sarah, you can leave now. Abdullah, I want to discuss your test result with you. So you will stay for 2-3 minutes more.
Thank you, ma'am.
Okay, Sarah? Okay. Okay, Abdullah.
Yes,
Now,
ma'am.
do you have that paper? With,
No.
okay, let me just open it. I think I have it.